Bismillahirrahmanirrahim. In this video, I will solve problem 5.21 that is based on a full factorial design from the book Design and Analysis of Experiments by Montgomery. The shear strength of an adhesive is thought to be affected by the application of pressure and temperature. The pressure and temperature become over variable or factors. A factorial experiment is performed in which both factors are assumed to be fixed. Analyze the data and draw conclusions. Perform a test for the non-additivity. So now if I come down towards the data, so you can see it here, I have 4 levels of the pressure from 120 pound per inch square to 150 pound per inch square, and then 3 levels for the temperature in the Fahrenheit from 250 to 270. Here we have only one replication. How we can say that? So you can see it here at the setting of 120 pressure and a 250 of temperature, we have only one replication and I got the value equal to 9.60. Then similarly at the temperature of 260 I got value of 11.28. At 270 the value I got is 9. So similarly there is only one replication for each treatment. To put this data in the Minitab, click on Stat, then DOE, Factorial, create a factorial design, and click on General Full Factorial Design. Then select the number of factors. I have 2 factors in this problem. Then click on Design. Here I will write their names of the factor. So I have the first of the factor is pressure, and the pressure has 4 levels. Then temperature has 3 levels. There is only one replication in this problem. Click OK, then go to the factors. Here I have to enter the values. So 120 is the first level, then 130, 140, tab 140, and then 150. Similarly, I have the temperature level from 250, 260, and 270. Let me verify it. Yes, from 120 to 150. Okay, fine. After that, click OK, then go to the option. Please uncheck this randomized run. Click OK. In the result, you will have nothing to do. Just click OK and then OK. So you got such a design. Click on here in order to view only the data. Slightly maximize it. Now here, write name response. Now what we will do? We have to input the data now. So at the setting of 120, you can see there are 3 times 120, and then in front 250, 260, and 270. So it means that first of all, we have to input the value for this 120 pressure at the temperature of 250, 260, and 270. So let me enter it 9.6, 11.28. So 9.6, 11.28, then I will write here 9. So in this way, I have input 3 values. Similarly, I will input the next 3 values for the temperature for the pressure of 130. So I will now then enter the values in the second row: 9.69, 10.10, and 9.57. To save the time, I have input all of the values so that you can pause the video and you can verify it while you are performing the same question in the Minitab. So once you have entered the data, then go to Stat for the analysis, then DOE, Factorial, Analyze Factorial Design, select the response, non-additivity. In the start, it will be empty and you will have to double click on it so that it will move it there. Then go to the graphs. In the graph, select 4-in-1 because we will have to satisfy the assumption before going towards the analysis. Okay. Then click on results. And then here select the expanded tables, because by selecting the expanded tables you will get the percentage contribution as well in the ANOVA table. Then click OK and the output, and whenever you come down, okay, the software is unable to plot the graph, as well as if we go up there is no F and P value obtained. Now this is the technical problem, why this problem has been arised. Because please remember, when we have only one replication in a full factorial design, there will be no degree of freedom left for the error term. This error term has 0 degree of freedom, and whenever we have 0 degree of freedom for the error, we are unable to calculate the sum of square, the mean MS error, mean square error. Okay, and when we haven't any value for the MS, so we are unable to calculate our F values and then associated P values. So in this case, what we will do, We will look at whether over highest interaction term. Highest interaction term means in this case two-way interaction, because we have only two factors and only the interaction, there will be one interaction term possible between the pressure and the temperature. So we see that the percentage contribution of this two-way interaction term is very high, 29.14, quite greater than the pressure, that is 7.86. So in this way we are unable to drop this two-way interaction term, and when we are unable to drop this interaction term, so we will keep our model as it is and we will conclude based on these percentage contribution. For example, we say that the highest percentage contribution is found to be for the temperature, followed by two-way interaction term, and the least percentage contribution on the response variable is of pressure. For example, if you people say that the pressure has the least percentage contribution, let's try to drop it. Now what will be happen? Go to the stat, DOE, Factorial, and analyze Factorial design. In the terms, when you want to drop this pressure, select it and then click on this arrow. The pressure will be moved there. Upon clicking the OK, you will get a pop-up message that you have specified a non-hierarchical model. The following terms are needed to make the model hierarchical, and it is also recommended by the software Minitab itself. So in this way, it is just for your information that please do not remove the individual terms of the main effect whenever we have the significant high level interaction terms. Now the second question, you can remove this pressure. So you have removed the pressure term and you move it there in the available terms. Click OK. You got this pop-up message. Nothing to do. Click here. Use the specified non-hierarchical model by your own choice. Click OK and then OK. So you will get an ANOVA table in which the pressure has been now dropped. You have only temperature and a two-way interaction term. Now there are degrees of freedom available for the error term, and you got the F values and the associated P values. And the model, it means that the pressure and temperature, they are contributing 92.14% variation in the response variable. And then if you want to draw any graphs, go to stat, then ANOVA, main effect plot, select your response variable non-additivity, and then select all of the response variable pressure and temperature. Click OK, and then you get such a graph. These are the main effect. So now what is meant by these graphs? For example, we want to minimize our response variable. So we will say that at a pressure of 140, our response is minimum, and likewise at a temperature of 270, we got our response variable value as the least one. In another case, if you want to maximize the response variable, then you say that a pressure of 150 and at a temperature of 260 Fahrenheit, we got our response variable value maximum. So that's all for today. Thanks a lot for watching the video. Bye.